Welcome to the Ventis MX4 online training module number 7. In this module, we will be discussing the maintenance that can be performed on the instrument. The Ventis MX4 was designed so that the basic maintenance can be performed on the instrument, allowing for maximum performance with minimal downtime. Items like sensors, filters, battery packs are consumable items. Therefore, they need to be changed out periodically. The instrument itself has a 2-year warranty and can be serviced at an authorized repair facility. If you have any further questions, by all means call Industrial Scientific toll-free at 1-800-338-3287 or 412-788-4353. The sensor is the heart of the instrument because it is what detects the gas. Considering this, it can also be the weak link. Understanding the operation of this technology is imperative to help extend the life of those sensors and maximize the instrument's overall performance. One of the sensors technologies that can be used in a Ventis MX4 is the catalytic diffusion. It is used to detect combustible gases and displays them in % LEL, lower explosive limit. Inside this catalytic diffusion sensor are 2 beads. One is called the sensing bead, which will be the one that burns the combustible gas, and the other bead is called the temperature compensating bead, which doesn't see any of the combustible gas at all. Both of these beads in fresh air will operate at a temperature approximately 500 degrees Celsius. Once the combustible gas enters the sensor, the sensing bead will start to burn the combustible gas on its surface. This action increases its temperature, which in return increases its resistance. Even though the combustible gas is entering the sensor, the temperature compensating bead will stay the same. The change in resistance between the 2 beads is what will be measured. That measurement of change in resistance is done by utilizing the Wheatstone bridge circuit in the instrument, which is then converted to LEL readings. This is the temperature compensating bead in the Wheatstone bridge circuit. This is the sensing bead in the Wheatstone bridge circuit. These are the 2 fixed resistors that are located in the instrument. As previously mentioned, the sensing bead will increase in temperature as it burns the combustible gas as it enters the sensor. This is an actual picture of the LEL sensor showing the sensing and compensating bead. One thing to remember is that you have to have 10% by volume oxygen for the sensor to operate. This is because the sensor actually burns the gas and we need oxygen to aid in the burning process. One thing we need to be aware of with the LEL sensor is there are some poisons that can affect its operation. Poisons will adhere to the catalyst bead. They will damage all or part of the sensing bead. The sensor will never recover if it is exposed to a poison. If you feel that the sensor has been exposed to a poison, a calibration should be accomplished to confirm its operation. If a sensor fails its calibration, then it will need to be replaced with a new one. A LEL sensor should last a good 3 years, but a poison will end its life instantly. The most common poison is silicone, which can be found in items like silicone spray and Almirall. It is important to keep these items away from the instrument to ensure that detrimental damage will not occur. Another caution with the LEL sensor will be the exposure to inhibitors. Inhibitors also adhere to the catalyst bead. They actually affect the long-term life of the sensor. The sensor can partially recover, but the damage may have already been done if exposed. If you feel that the sensor has been exposed to an inhibitor, a calibration should be accomplished. As I said before, inhibitors affect the long-term life of the sensor, which means instead of lasting 3 years, the sensor may only last 1 to 2 years. The most common inhibitors are high sulfur compounds, lead or gas additives, and halogenated compounds that are found in CFCs, things like astatine, bromine, fluorine, chlorine, and iodine. The next sensor technology used in the Ventis MX4 is the electrochemical sensor. If you could see the inside of this sensor, this is what you would see. At the top is the Teflon membrane, and underneath that is the capillary tube. The capillary tube is where the gas enters into the electrochemical sensor. Going down even further, there is an O-ring, which holds the parts of the sensor together. Underneath the O-ring, you have your working electrode, your reference electrode, and counter electrode. These electrodes are made of precious metals. These different metals give the chemistry needed to detect the specific gas that the sensor is made to detect. As well as the electrodes, you have the spool wick and then the electrolyte reservoir. This screen shows the same thing you saw earlier. You have your 3 electrodes and the acid electrolyte. Some say it's just like a battery. Now the difference between a battery and an electrochemical sensor is that the battery is always producing current, and the electrochemical sensor is only producing a current when the gas that it is designed for enters the sensor. Once the gas that the sensor is designed for enters, it is then that the electrolyte creates a chemical reaction within the reservoir, and that chemical reaction will then react with the electrodes and a current is produced. Depending on how high the concentration of gas is within the atmosphere is how much current the sensor will actually produce. So in essence, your Ventis MX4 is a basic digital multimeter measuring the current the sensor is producing. The higher the gas it is exposed to, the higher the current the sensor produces. This in turn gives a higher reading of measurement on a display of the Ventis MX4. This screen shows what I call the electrochemical sensor response curve. What this screen is showing is that it typically takes 30 seconds to respond to 90% of the gas that is in the atmosphere you are testing. To respond to 100% of gas in the atmosphere you are testing, it typically takes 2 minutes. What this tells me is that if I'm monitoring an area, I can't just continuously walk around the area to read the presence of gas. What I need to do is stand in one spot and wait at least 2 minutes to make sure that my sensor is seeing 100% of what's in the atmosphere. Once I have waited 2 minutes and my instrument still reads 0, I can now step to the next area that I must monitor and do the same thing over again. Electrochemical sensors that are available for the Ventis MX4 are oxygen, carbon monoxide, hydrogen sulfide, nitrogen dioxide, and sulfur dioxide. The Ventis MX4 has a 2-year warranty, but as mentioned before, the sensors in the instrument have a life expectancy that can be best determined during calibration. A date code is also provided on the sensors to help determine if it's past or within warranty. The date code for the catalytic diffusion sensor can be determined by looking at the first 4 numbers of its serial number. The first 2 numbers are the year in which it was made, and the second 2 numbers are the month in which it was made. As you can see, this sensor was made in March of 2010. The date code of the toxic sensors can be determined by looking again at the first 4 numbers of its serial number. The first 2 numbers are the year in which it was made, and the second 2 numbers are the month in which it was made. As you can see, this sensor was made in January 2010. The date code for the oxygen sensor can be determined by looking at the last 3 numbers of its serial number. The first 2 numbers are the month in which it was made, and the last number of the 3 is the year in which it was made. As you can see, this sensor was made in June of 2010. The lithium-ion battery pack also has a date code. This will help determine if the cells are past or within warranty. The date code for the lithium-ion battery pack can be determined by looking at the first 4 numbers of its serial number. The first 2 numbers are the year in which it was made, and the second 2 numbers are the month in which it was made. As you can see, this battery pack was made in January 2011. The instrument also has a date code. This will help to determine the warranty status of your Ventis MX4. It is located on the top of the diffusion model. If your diffusion model is used with a pump, then it can be found on the side of the instrument. The date code for the instrument can be determined by looking at the first 4 numbers of its serial number. The first 2 numbers are the year in which it was made, and the second 2 numbers are the month in which it was made. As you can see, this instrument was made in January 2011. The Ventis MX4's pump also has a serial number and is located on the back of the pump assembly. The date code for the pump can be determined by looking at the first 4 numbers of the serial number. The first 2 numbers are the year in which it was made, and the second 2 numbers are the month in which it was made. As you can see, this pump was made in May 2010. To remove the battery pack, first loosen the single captive screw on the front of the instrument. Once the screw is loose, slide the front pump door forward and lift to expose the instrument. Next, rotate the instrument on its back and loosen the 4 captive screws located on the back of the pump housing. Rotate the instrument to its front again and remove the instrument from the pump housing, exposing the battery pack inside. Simply remove the battery pack from inside the pump housing. Here you will see a video on how to remove a battery pack from the instrument. First, if the instrument is on, hold down the on-off mode button for 5 beeps to shut the instrument off. First, loosen the single captive screw on front of the instrument. Next, rotate the instrument on its back and loosen the 4 captive screws located on the back of the pump housing. Rotate the instrument to its front again, slide the front pump door forward, and lift to expose the instrument. Remove the instrument from the pump housing and expose the battery pack inside. To remove the sensor from the Ventis MX4, follow the previous mentioned steps, and once the 4 captive screws are loosened, remove the instrument from the pump housing. Rotate the instrument on its back and remove the 2 remaining captive screws. Separate the 2 case halves to gain access to the sensors. Simply pull the sensor from its connection. This video demonstrates how to remove a sensor from the Ventis MX4. To remove a sensor from the MX4, follow the previous mentioned steps, and once the 4 captive screws are loosened, remove the instrument from the pump housing. Rotate the instrument on its back and remove the 2 remaining captive screws. Flip the instrument to its front and separate the 2 case halves to gain access to the sensors. Simply pull the sensor from its connection. To install a new sensor in the Ventis MX4, simply line up the sensor connector with the connector on the instrument's board and gently plug the sensor into the board connector. Here you will see a video on how to install a new sensor. To install a new sensor in the Ventis MX4, simply line up the sensor connector with the connector on the instrument's board. Then gently plug the sensor into the board connector. The Ventis MX4 can be configured as a single gas monitor or a multi-gas monitor utilizing a combination of 1 to 4 sensors and has 6 gases from which to choose. To reassemble the Ventis MX4, first place the front sensor half over the back half of the instrument and secure with the 2 captive screws. Install the battery pack into the pump assembly. Install the instrument into the pump assembly. Turn the unit on its back and tighten the 4 captive screws. Rotate the instrument to its front, close the front pump door, and slide the door forward until it locks into place. Tighten the remaining captive screw on the pump door to secure. Here you will see a video on reassembly of the Ventis MX4. To reassemble the Ventis MX4, first place the front sensor half over the back half of the instrument. Rotate to the side and secure with the 2 captive screws. Slide the pump cover open, install the battery pack into the pump assembly, install the instrument into the pump assembly, close the pump door, and slide forward. Rotate the instrument to its back and tighten the 4 captive screws on the pump housing. Rotate the instrument to its front and tighten the remaining captive screw on the pump door to secure. Finally, remember, if you ever have any questions regarding the Ventis MX4 or any other instruments industrial scientific manufacturers, please don't hesitate to call us. Our technical service center can be reached toll-free at 1-800-DETECTS or 1-800-338-3287 or 412-788-4353.